Alright, here's the video for the mile marker practice. We will be taking the mile marker on either the 20th, which is a B day, or the 21st, which is an A day. So heads up on that. Okay, so we are going to be simplifying. So on the first 7, not number 8, the best way to get through these problems, because you will not have access to a calculator, you will have access to an exponent table if you need it, is to loop them. So putting an equal sign with a question mark is the way we did this. So I'm going to do that real quick. And then loop it. So this is a log. I'm going to loop it into an exponent. So go 7 to the what power gives you 1. And that would be the 0 power. So I'm going to loop this. 4 to the what power gives you 4. And that would be the first power. So the answers are on the left. 2 to the what power gives you 32. This is one you would probably want to look up on your exponent table. When you look it up, you will see that it's worth 5. And then 3 to the what power gives me this fraction. And again, we've talked about that what makes a fraction and exponents are negative exponents. So just realize that there's a negative exponent that's moving the 27 down. So first I'm just going to figure out 3 to the what power gives me 27, and that's 3. Your exponent table can help you with that. And then what moved that 27 from a numerator to a denominator was making it a negative 3. Alright, so looping, again, this is a log problem. I'll be looping it into an exponent. This log has a little base of e here that they don't write. So e to the what power gives me all of this. Well, I just need these exponents to match up. So here my answer is x. This is an exponent, so I'm going to loop it into a log. And so I write it as a log. And it goes log with the base of 10 of the question mark equals that. And again, I just have to figure out what that question mark is going to be worth so that the left is the same as the right. And so it's going to be 9. The next one, so again, e to the what power, well, sorry, let me back up. This is an exponent problem. I'll be looping it into a log. So log, and then I put the e, and log e, again, you guys, that's just ln, so I'm going to rewrite it. So ln of the question mark equals all of that. Whoops, sorry. So what does the question mark have to be worth to make the left side equal the right side? That would be a 6. And then the last one. In this one, we are escaping exponents and logs. Your job is to tell me what 16 to the 3/4 power is, which I don't know off the top of my head. But if we rewrite it as a radical, and this is going back to chapter 5, the denominator becomes the root number or the index number. So I would take the 4 through to 16, which is 2, and then I'm supposed to take that 2 and cube it. So this is what I'm doing. And again, your exponent table would tell you that that's worth 8. So on this one, we got rid of these negatives. And sorry, 1B, I did not tell you that, so hopefully you are watching the video. And you have to tell me about the domain and the range. So logs either go like this if it's growth, or it goes like this if it's decay. These are our two shapes for logs. And you look at the base, and ln, again, is a little base of e. And when the base is bigger than 1, it's growth. So this is the shape that we're working with. And then these problems have a wall. So exponents have a wall, and logs have a wall. And since log, the word log goes up and down, that's the way your wall goes. And it's always on this side for us. And then you have to figure out where this wall is placed, and that's where you go to your left-right number, also an L. And you want to ask yourself what makes that 0, which is -3. So that's where my wall is where x is -3. And now we do the domain. So we talk about, you know, as we go to the left, x is getting smaller, but will hit a wall, and it will hit this wall of 3. So my domain is -3. I said 3. And then as I go to the left, y is getting smaller. Will it hit a wall? No, it's going to keep going down, so we put -infinity. And then over here, as we go to the right, x is getting bigger and bigger. Will it hit a wall? Nope, so it's infinity. And then as we go to the right, y is getting bigger and bigger and bigger. Will it hit a wall? That's supposed to be infinity. No, it's infinity. And now you can write your domain. So the domain are the x values, the smaller one to the bigger one. So my domain is from -3 to infinity. Okay, and the range, we look at the y values, so smaller to bigger. Okay. All right, the next part we are just rewriting. So exponents, I want them to look like logs, so they'll look like this, and then these logs, I want you to write them as exponents, so they'll look like this. So you just do the loop. Since these are exponents and they're writing as logs, put the log, and it goes 3, 243, and 5. And you guys, you have to write them the right size. This has to be small, and these have to be normal. So again, I'm going to write this as a log. So log, it goes E, and if you write that, that's fine, but technically that's the same as ln. And then I put 27, and then that's going to equal 3x. So we're just practicing the loop. Now these are logs, so I'm going to write them as exponents. So I start with the base, and it goes a to the 1.8 power equals 21. And again, you guys, you have to write them the right size. So these should be normal, and this should be small and raised up to the right. And ln, again, I need a base. That base is always e, so it goes e to the 8th power equals x. Okay? That 8, again, has to be small and raised up to the right. All right, final part. We are expanding and condensing. So we've talked about that multiplication turns into addition or vice versa. Division turns into subtraction or vice versa. And then exponents turn into multiplication or, again, vice versa. So what I want to do is look at this first as exponents. And a square root is like a 1/2 power. I'm just ignoring the log. And what I see is a squared times b to the 1/2 divided by c cubed. And what's going to happen is this is going to turn into addition, and this is going to turn into subtraction. And what we're going to do is we're going to expand this so that we don't have one log. We have 1, 2, 3 logs. And I just put the log. Its base is 10 when it's not written. You don't need to write the 10 though. And a squared. But the squared doesn't stay here. It actually moves to the front and turns into multiplication. Plus, then I have log with b to the 1/2. And again, the 1/2 doesn't stay there. It goes to the front. And then minus the log with c. And then the 3 doesn't stay there. It goes to the front. And now I have expanded it. All right, so condensing, I'm going to do the exact opposite. Instead of having 3 logs, I want it to look like this. So it's just 1 log. So this last step where I move them to the front, that's actually the first step I'm going to do here. So this is going to go back and be a 1/2 power. And this is going to go back and be a squared. And now just ignoring the logs, it's 9 to the 1/2 plus 12 minus 4 squared. We're going to go back and turn the addition into multiplication and the subtraction into division. At this point, turning 4 squared into 16 is a good idea. And then again, this is 9 to the 1/2 power. It's not half of 9. And a 1/2 power, remember, is like a square root that we did over here. So we're really just taking the square root of 9, which is 3. And what I want you guys to do is clean this up. So 3 times 12 is 36. And then over 16. And then hopefully you see that you can simplify this. For instance, I could take a 4 out of both of these and get a 9. And then a 4 here. And then just bring that log back. So this is just going to have that log with the little b in front of it. So I'm going to write it up here. And now we've condensed it. Okay? And that's your video on the mile marker. And again, we will be doing that the day we do the retake, which is going to be on the 20th.